Hi students, this is Ms. Overly with 7-6 Similarity Transformations. By the end of this lesson, you will be able to identify and use similarity transformations to solve problems. So right away, we're cueing into that idea of similarity. Remember, with triangles, we have certain ways to tell things are similar. And with other shapes, how do we tell? What's that big idea there? Before we get started, there are some terms I want to go over with you. Why don't you watch first and then think about what you want to write down. I would say the big ones are dilation. Actually, I would say that is the big term. A dilation is a transformation that enlarges or reduces the original figure proportionally. So the big idea here is everything should be proportional. So with the dilation, the two new shapes are similar. And we call that a similarity transformation just because they are similar. The center of dilation is where it all starts. It's a fixed point. And the scale factor of dilation is exactly what you're thinking. It describes how much bigger or smaller the shape got by using a proportion to come up with that number. K is what we usually call the scale factor. An enlargement just means it's getting bigger, so that K is greater than 1. No, you don't need to write all this down. A reduction is when that scale factor, that K, is between 0 and 1, and the shape got smaller. So from here to here, our shape got smaller, so that scale factor would be a number between 0 and 1. Example 1, determine whether the dilation from A to B, so from blue to green, is an enlargement or a reduction, then find the scale factor. So from blue to green, you can tell what's happening here. It's getting smaller, so it's a reduction. Remember, the scale factor is just that fraction of what happened, so we just need to measure two corresponding sides. So it's a reduction, and we could count that distance from here to here. It's 1, 2, 3, 4, 5, 6, which is why I chose that side. And this side is, it looks like 1, 2 plus a half on each side, which is 3. So from here to here, it got smaller by 3/6, or 1/2. All right, from A to B, so from blue to green, it got larger, which makes this an enlargement. See if you can count the corresponding side, that measurement on each side, and come up with that scale factor. So this is a little under 1, 2, 3, 4. And this is 1, 2, 3. So that's getting bigger, so it's 4/3. We know our scale factor for an enlargement will be greater than 1. We know our scale factor for a reduction will be between 0 and 1. Example 2, refer to the beginning of the lesson. By what percent would Adriana enlarge the ticket stub so that the dimensions of its image are 3 times that of the original? What will the dimensions of the enlarged image be? So 3 times is exactly what you're thinking. We can just multiply by 3 or 300% to get 15 centimeters by 19.2 centimeters. Finally, and here's where it gets a little bit more challenging and we have to use our geometry skills, we are going to graph the original figure and its dilated image, then verify the dilation is a similarity transformation. Remember, for triangles, similarity means that sides are proportional and angles are the same. And the same thing is true for any other shape. So why don't you pause the video on your graph paper and graph these original and images, and then play it when you're ready to move on. All right, so you've graphed both the original and the image. And in order to determine that this is a similarity transformation, we need to check that the sides are proportional. So go ahead and take the measurements of the two sides we can just count. And you will notice that we're getting out 2/3 and also 2/3. So since those sides are proportional, and that's XZ and YZ, so we just notice that These are proportional. I'm marking them with congruent marks, but they're really not congruent. They're just proportional. And we can see that they're sandwiched by a right angle. So by side angle side, this triangle is similar to this triangle. All right, check your graphing here on this last piece, and you should have two rectangles like this. You can see all the work that's been done here to find the distance of each side, or the distance between each of these 2 points, so the length of each side. Once you've done that, you can line up corresponding parts and find out if they are proportional. And this part is all algebra, but you're literally just doing this side to this side, this side to this side, this side to this side, and find out, are they matching up? And if they are proportional, we know that these shapes are similar.